And then our next speaker is Dwayne Freund from the University of Illinois Extension, and the title of his talk is Biochar and Low Organic Matter Soils.
Okay, thank you very much. When I talk to a group like this, I always have to ask first, how many of you are familiar with what Extension is? Okay, a few of you, that's good. How many of you would feel comfortable enough that if I pointed to you, you would be able to explain it to the others? Not as many hands, okay. Well, for those of you that aren't familiar with Extension, all land-grant colleges and universities, or the 1860, the ones that started in the 1860s, had an outreach component that started in the early 1900s. That's what Extension is. We're an outreach arm of those universities. We take research that's done at those universities and turn it into public education programs. And that's one of the things that I do. I work in the area of soil and water management mainly. So when I'm dealing with things like biochar, and my interest in it is as a soil amendment, I'm dealing with it to the general public mostly. So I have to put it in those terms. And if I'm talking to a group of farmers, when I'm dealing with this as, again, a soil amendment, they're going to look at me and say, well, okay, all of this research is good. Show me what it does on a field. And so that's the main reason I did this particular research, field research, was to do this, to show what would happen in a real-world situation. I do want to go ahead and acknowledge people that have helped with this. I did have a small grant from the Illinois Department of Agriculture, the Sustainable Ag Grant Program, and I've also got help from the Illinois Sustainable Technology Center, so I wanted to thank them for their assistance with this. As far as the field study details, and one of the things that was mentioned this morning, and part of this is going to kind of dovetail what was talked about this morning. If you look at most soils in Illinois, particularly in the central and northern part of the state, you're probably not going to find a big response to biochar because these soils are inherently highly productive. We have mostly mollisols, we have high inherent organic matter content, high mineral content, so they're already fantastic soils. But there are a few areas in the state where that's not the case. And that's the areas that I wanted to look at those areas that may have some benefit from using biochar as a soil amendment. So I took 3 sites in west central Illinois, and these are relatively small plots because, again, trying to find large amounts of biochar is still kind of difficult to do. But I did 3 replications where we had the control. We had 10 ton per acre rate. We had 20 ton per acre rate. And these were in, again, small 10-foot by 10-foot sections. Each of those sites were planted to field corn. This was last year. We used normal agronomic practices on these sites. And the things I was doing last year was mainly examining soil to see how it would change over time. We looked at the yield content of each plot over the year to see what would happen with that. These show the sites. Again, they're in west central Illinois. One of them is in Mason County. Mason County is kind of unique. There's some other areas similar to the up around the Quad City area, but Mason County is mostly alluvial sand. You go through about 85 feet down to bedrock, anywhere from 85 maybe to over 100 feet of nothing but sand. So it's totally different than what you would see in other parts of the state for the most part. The one that's called Site M up there, that's actually part of a conservation area. The longer name for it is the Jim Edgar Panther Creek Conservation Area. It's mainly a conservation area, but they do have some sites on there where they still have land that's rented out for farming operations. So we used a site on that one. Again, it's a very low organic matter soil, probably originally would have been under trees. And then the third site is down in beautiful Calhoun County. Calhoun County is, again, a fairly unique site. It's sandwiched right in between the Illinois and the Mississippi rivers. Probably the total width from one river to the other at most is maybe about 10, 15 miles. So you basically go up one river valley down to the next. And so it's also an area where there's a lot of original timber being there, mostly alpha sols in those areas. Just talk a little bit about each one of these sites real quick. For this site, it was at a conservation area called the McCullough Heritage Farm. This original land, or the land previously to putting the plot in, had been in alfalfa. It was plowed. We put the biochar in, tilled that in, and for this particular site, it was actually hand seeded for the corn, but it was seeded at normal agronomic rates. We used Roundup Ready corn on all of these sites. And this is kind of what the site looked like right after application. You can see again where we put the plots, and you can see the control in there in between those. Here's a picture of the site about mid-June. Now right there, it looks not too bad, but this was also at the very beginning, and we all probably very well know what last year was like in terms of weather conditions. It was turning off very hot, very dry, and you can start to see almost a little bit of moisture stress even on this at this point. So we had to contend with that at all three of the sites. The site that was in Mason County, this was a plot that was originally or previously in field corn, but this is also a plot that was supplementally irrigated. So we're able to add a little bit of water to that. It was also planted with Roundup Ready corn by a farm operator. As I said, this site is a little bit different than what you'll see in other parts of Illinois. Right about 10 feet away from where the plot was, I took this picture of prickly pear cactus. So yeah, it's not what you would typically find in most Illinois locations. This is what this site looked like right after application. And here's the site a little bit later. You can see the irrigation in the background. But you can also see this site is already exhibiting moisture stress, even with that irrigation. These sandy soils, particularly this particular area, it was almost impossible to keep up with the moisture needs for the corn, even with supplemental irrigation in these areas. And then the other site in Cass County. This was a plot that was previously in soybeans. This one was a little bit different in that it was part of a strip till field. So it was done a little bit differently. So you kind of have to think of these as three separate situations. This was also planted to Roundup Ready corn by a farm operator. And this is what this site looked like. And actually, it may not look like it was put on quite as heavily, but this was right after. Since it was a strip till plot, none of this biochar was going to be tilled in. So I tried to go through and at least work it in a little bit manually by a rake to at least get a little bit of soil interaction there. And that's what this site looked like at about mid-June. You can already see, again, with the corn there, it's exhibiting moisture stress. Looking at the organic matter content. Now, for the control, if you look at the control in all of these, this would have been similar to what all of the plots would have been like before application. So you can see in the Mason County plot, all of them were at or just a hair above 1% organic matter, even after application. For the Cass and Calhoun sites, a little bit higher. You can see that with the biochar plots, particularly in the Cass, they did have a pretty good increase in organic matter content. For some reason, not so much for the 10 tons per acre rate in the Calhoun site. Not quite sure why that was the case for that one. For CEC values, and this kind of dovetails into what some of the other folks were saying earlier. The CEC values really weren't seeing any big change in any of those, and in fact, in some cases, it almost looked like a slight decrease in cation exchange capacity where the biochar was applied. And again, this was in July of last year. Now, going on to the yield, like we said, we had a lot of very poor weather conditions. Yields, typically in any of these soils, would normally be around 150 bushel an acre. Well, you can see in some of these, particularly a few plots had 0. I could go through there and I could pull off ears, and there would maybe be one kernel on that ear. It was just nothing, just because of the weather conditions. So we had a lot of variation. You can see at the Calhoun plots, again, just all over the board in terms of yields with that. Even with the 20 ton per acre plots, we had a lot of variation with those. For the Mason County plots, again, lots of variation, and part of that can probably be attributed to the fact that it was a small plot. We also had problems there with insect infestation from Japanese beetles, and so it just too much variation there I didn't even run statistics on it because it wasn't going to be worth it. Cass County plot's a little bit less variable, and actually had the highest yields there, but even there the yields at most got up to about 50 bushels per acre, which is about a third of normal. And you can see again lots of variation there, really not any clear-cut evidence that the biochar really helped a whole lot in that first year. I came back later in the fall, did some more soil sampling for the organic matter content. Again, for those you can see that the biochar applications are showing kind of what you would expect. You're going to see the increase in organic matter contents in those areas where the biochar was applied. CEC values still showing where the biochar was applied in a lot of cases. It was actually showing some decreases. Again, probably too much variation there to really call it statistically significant. And then this year, went out before anything was planted, did some soil sampling again. Organic matter contents, again with this, are still showing a little bit of benefit from the biochar application. CEC values, still showing very little or maybe a slight decrease where the biochar was applied in the cation exchange capacity. One thing I started to look at a little bit more for this spring, and again this was mentioned somewhat this morning, was the pH value. It looked like at least two of the sites, we maybe start to be getting a little bit of a pH boost from that. And if it's not too much, in a lot of cases we do have to add limestone to these areas to bring the pH values up. So if it isn't too high, this may have some promise as a liming agent. So that's something I'll have to continue to look at a little bit down the road. Now, like I say, with all field research, you have to deal with variables. This is a picture taken last week at Mason County. They had just gotten this planted about 2 weeks ago. There was a storm came through, and where that stuff fell down was right in the middle of two of my plots. So since then, they've removed that, and we had to basically start over again. Otherwise, it would have been a washout for the entire year. So we've had to go in, and even though it here is mid-June, they had to replant it. So we'll take what we get and move along with it, but we'll continue to monitor that one and see how it goes. So again, we're going to continue to look at soil values. We're going to look at yield at the end of the year. We're going to continue to do this, and we're not planning on applying any more biochar to these particular plots, but we are going to continue to monitor the plots, hopefully for the next 2, 3, 4 years, and see what happens with it over the long term. One of the things that was mentioned this morning that really piqued my interest, at some of these areas, particularly at the Mason County, I have done some other studies in the past with compost, but I haven't used compost and biochar, so I may try to do some adjacent plots with compost and biochar and see how that works. So with that, I'll stop and ask if there's any questions. Yeah?
I had a question regarding the organic matter.
Uh-huh.
You should be able to analyze your char and tell how much organic matter is in there. And you know how much you have in your soil. If you mix those together, I assume that they're additive, you should come up with a number.
Mm-hmm.
Have you done that calculation to compare those just theoretical number versus what you get?
Okay, the question was whether we've taken the biochar and analyzed that and then compared that to how much organic matter we're actually adding to the soil. I've taken my biochar into the Sustainable Technology Center, and I believe they've analyzed that. I'm waiting to get that information back and looking at those numbers at that point. Yes?
Assume that most of your organic matter is done by loss substitution. It may not actually crank it up to ether to get the biochar to break down.
Well, that's another good point. And if you noticed, and I didn't really point it out that closely, if you looked at the Mason County organic matter values in May, they were much higher than what they were last fall. So, and I've noticed even with those small soil organic values on a lot of soils, Every lab's supposed to be doing things the same way, but I've seen variations from soil lab to soil lab. So you're absolutely right with that. Yes? Mm-hmm.
So in that sense, that data actually is not telling.
Okay. And that's one of the things, too, that I'm guessing that the Sustainable Technology Center, they'll be able to give me some of that information in terms of CEC value just of the biochar itself. So, good point. Yes? Well, you mean in terms of the strip till? Because two of the locations, they did till it in. It was either tilled in by a disc or something similar to that. For the strip till operation, their normal operation was to apply things just in strips, not disturb the residue, and put in their crop that way. So that one was kind of a unique situation. And to be honest, this year, this year in that particular site, they're putting in soybeans. And they did go back and till it this year. So that site has had some of that worked in more than what I did last year. So there would be a lot more interaction between the biochar and the soil at that part. But the other two sites, they did get worked in, in the 3 to 4 inch level. I'm sorry, about the yeah, and we want to follow as much of the normal ag operations as we can because, again, if we're going to make this something that is going to pique a farmer's interest, they're going to want to know what's going on that they can do that they're normally going to be doing in terms of their tillage operations. So.
Okay, let's thank
Thank
the
you.
board again. Thanks, Phil. Okay. Our next speaker is Raymond Byen. With the title of this talk is The Long-Term Effects on Biochar on Select Soil Enzyme Activities.
Thank you.
Okay, maybe clip it to your shirt.
I told you that I'll be back.